Good morning. Today we are going to discuss about reflection of sound. When you speak in your room, you can hear a soft repetition of your voice. So this is reflection of sound. When the sound waves strike a surface, they return back into the same medium. This phenomenon is called reflection of sound wave. The only difference is that sound waves require bigger surface for reflection. Then reflection of sound waves takes place in the same way as reflection of light waves, which means reflection of sound waves also like as light waves. Sound waves is also obeying the laws of reflection. Laws of reflection. Sound wave is reflected back to the solids. A source is emitting the sound wave. That one of the sound wave that strike on a solid surface. So this is the wave called incident wave. Then a line is drawn on a perpendicular to the point of incident. This is called normal. Now this way, that instant wave reflected back to the surface. This wave called reflected wave. The angle of incidence is called I. The angle of reflection is denoted by R. The angle of incidence I is equal to angle of reflection R. Suppose the angle of incidence is I equal to 30 degree means the angle of reflection R also 30. Then the angle of incidence, the angle of reflection, then normal are lie in the same plane. Let us discuss with one example. Two hollow tubes are arranged in the plane surface on the table. A ticking clock is placed near the one end of the tube. A screen is placed between the two tubes so that the sound is not reached by our ear. At the other end of the tube, directly we can hear the ticking sound. The tube is moved in various positions. This process is continued till where we reach the most distinct sound. Then we measure the angle of incidence I. Then we measure the angle of reflection R. We can compare the angle of incidence I and angle of incidence R. So angle of incidence I and angle of reflection R are equal, and angle of incidence I, angle of reflection R and normal are lie in the same plane. Next we are going to discuss reflection of sound at the boundary of denser medium, reflection of sound at the boundary of rarer medium, reflection of sound in plane and curved surface. First of all, we are going to discuss what is denser medium and rarer medium. Denser medium, the medium in which the velocity of sound increases when compared to the other medium, called rarer medium. For example, solid is rarer medium when compared to the air for sound wave. Then rarer medium, the medium in which the velocity of sound decreasing when compared to the other medium. For example, air is a denser medium when compared to the solid. Then reflection of sound at the boundary of denser medium. Sound is a longitudinal wave. A longitudinal wave travel in the medium in the form of compressions and rarefactions. Series of low region called rarefactions, series of high region called compressions. The compressions travel in air from left to right side that strike on the rigid wall. According to the Newton's third law, for every action there is an equal and opposite reactions. R equal to minus F. The compressions, when striking the rigid wall, the energy is transferred. As a result, compressions near the rigid wall is reflected back to as a compression. Compressions travel right to left side. So compressions again return back into the opposite direction. Next, reflection of sound at the boundary of rarer medium. Let us consider a wave is traveling solid medium that strikes an air medium. The sound wave interfaces between the solid and air. The incident wave travels from left to right direction. The compression exerts force on the surface of rarer medium. A rarer medium has small resistance, and the particles of rarer medium are free to move. Compressions reflected as a rarefactions. Rarefactions travel from right to left in opposite direction. Then next is reflection of sound in plane and curved surfaces. When a sound waves are reflected from the plane surface, the incident wave is equal to the angle of reflection. The intensity of incident wave and the reflected wave are same, does not change, but the sound waves are reflected from the curved surfaces. The intensity of reflected wave change when a sound wave is reflected from the convex surface. The reflected wave are diverged that cause intensity of sound wave is decrease. When a sound wave reflected from a concave surface, the reflected waves are focused at one point so that the intensity of sound increases. In parabolic surfaces, the reflected the sound wave to focus on particular point. So only many auditorium halls designed by parabolic safe. In elliptical surface, the reflected sound wave focus on one point and that always reflected to the other focus. This principle is used for designing a whispering hall. The famous whispering hall is a St. Paul's Cathedral Church in London and Golconda Fort in Hyderabad.